Content over everything!
Or very massive objects, then Newtonian gravity kind of has to succeed to something else. But for everyday objects like us standing on the surface of the Earth and water on the Earth, Newtonian and bridges and aircraft and all those sort of things, a lot of technology is based on an understanding of physics that includes Newtonian gravity. So I'd suggest that actually it's been confirmed day after day after day. Every time you get out of bed, every time you get into a car, every time you have a bath.
Check this out, right? Have you heard of a thing called potential energy before?
Yes, of course. I did A-level physics.
Right. So nothing can fall unless you drop it. Yeah. So I've just gave this potential energy, yeah, by picking it up.
Potential energy.
Right.
That's right.
Yeah, but it wouldn't have had.
It
wouldn't. Yeah, exactly. Yeah. Right. But the location's in my hand. I picked it up and gave it potential energy. Now I'm going to drop it. Yeah. It only fell because I dropped it. Yeah. There's no gravity at play there. It's density. It fell because I dropped it. Yeah.
And have you not noticed that?
And can I say something? Because if you're a physician, then you might be able to answer this. So if I get a ball now and I tip the water around the ball, why is gravity not holding that water to that ball, but it will hold water to the?
Because the forces involved are so small. Because remember, the gravity is actually quite a weak force when you talk about small objects. Wait a minute. Compare with the electric. For example, compare with magnetism. I mean, if you pose that about a magnet, two magnets, they would actually cling together, wouldn't they? You know that. In defiance of gravity. Say you had two magnets like that, and you, instead of dropping, they would probably do something like that. They would come together. Because magnetic forces are very, very strong compared with gravity. But although gravity is relatively a weak force, there's a hell of a lot of matter. I mean, the mass of the Earth is such that the force between my body and the Earth is enough to stick me to the ground. That's the point. Or when you release the ball, it's enough to allow it to drop, overcoming air resistance. Now, if you're in a spaceship, you must have seen pictures from NASA, or people playing around in well, you probably can test all that. But I would simply suggest that there is no reason to doubt NASA.
There's no reason to doubt NASA.
I have
not really, but I'm sure you can give me plenty of reasons.
They're not
right? Okay.
How is the gravity force that selective in selecting the light objects? How is the gravity force that selective to actually hold big objects down like mountains and seas while letting flies and small things just wander around freely? What kind of selective force are we dealing with here?
Because
is it magnetism?
Flies don't get a free pass. Remember, when you look at an aircraft, there's a huge amount of energy has to be expended in terms of fuel. You've seen them fueling up an aircraft. That's all energy that has to be expended to push the thing up into the air. Same with a bird or a fly. It doesn't get a free pass. A bird or a fly actually has to move its wings,
what is this
which it
kind
gets from the energy
What is this kind of force? I've never seen it before that actually gives permission to small objects to actually spend less.
I'll tell you exactly why. In mathematics, F force equals big G times m1 times m2 divided by r squared. So, F, that's the force between two objects. Any two objects in the universe, you and me and the Earth, me and Sam and his hat, atoms, everything, you can calculate a force, big F, equals big G, that's what they call a constant, it's a number.
Yeah, you can calculate it as much as you need, but can you actually see it?
Do you want to listen to me?
Yeah, sure,
explaining your question, really.
Yeah, sure.
Well, the next two terms are M1 and M2. M1 is the mass of object 1, M2 is the mass of object 2, divided by r squared. R is the distance between the two objects. So that neatly sums it up. So if you like, in non-mathematical terms, what it means is that the gravitational force between two objects is directly proportional to the multiplication of their masses. So the Earth is a big mass, I'm a little mass, so that's a big number, divided by r squared. So that means that the force diminishes by the square of the distance. So in other words, if you double the distance, you divide by 4 the force, and so on. So in other words, it's not a linear fall off, it falls off like that.
That means that two mountains, big, huge mountains beside each other, there is a force between each
every
other.
object in the universe attracts every other.
I've never seen that.
Can I just say something?
What would you be looking for? How did you look for it? Can I finish?
Has anyone measured that before?
Yeah, they do, of course they do.
Where?
All the time.
How?
Nobody's measured it.
Of course they do. I mean, geologists will measure magnetic anomalies. They can detect areas of higher mass underneath the Earth. So don't read a textbook on geology.
So you're saying it's magnetic force? But magnetic force does not work like
Did I
this.
say magnetic?
Yes, you said magnetic field. You said magnetic field and force.
If I did, I misspoke. Geologists can detect forces between, or anomalies, if you like, due to large masses. So, or denser masses, if you like, in the Earth's surface. I mean, you can get maps. Go to the Geological Museum. You will find maps of I might have said magnetic. Sorry, it was I scrubbed that. Gravitational anomalies. In fact, interesting one. There was a discovery of a large gravitational anomaly with the orbit of the Hubble telescope. Because what they were finding when the launch, because it's quite a low orbit. And what they were finding, that they were getting a lot of breakdowns in the telescope electronics at certain points in its orbit. What happened was that essentially that there was a gravitational anomaly that was pulling it down. And it was pulling it. Oh, wait a minute, I've got this wrong. There was essentially an anomaly in the mass of the Earth.
That's a story from.
I know, second-hand information.
Which results in a diminution of the atmosphere above it, something like that. I might have got it wrong. But anyway, so it had less protection from radiation. But it did lead to the understanding that there are areas of the Earth's surface that have denser matter underneath the Earth's surface. So that's one little example, but you'll find loads. Pick up a geology textbook.
How would, you were talking about earlier that gravity affects things of larger mass, yeah? How would you demonstrate that? How would you demonstrate that gravity affects things of larger mass?
You get two objects.
No, I mean like you're talking about planet-sized things. How would you demonstrate that?
Well, as soon as Newton...
No, listen, science is built on observable, testable and repeatable information, and experiments. So how would you demonstrate that now? Like, how would you what?
Halley's Comet.
A comet?
That was
a comet that we can't observe right now?
Well, we observe it every 70-something years.
70-something, so I've got to wait 70-something years to prove something.
You seem very, very kind of parochial in your view. You seem to not recognise that for centuries, scientists have been
you're trying to come at me with pseudoscience, mate, right? Listen, you can't... I want proof. I want you to show me proof. Show me this tangible thing.
We're in time and age now where we can actually minimise the scale of huge experiments and actually do very small things of them. Most of the things that are proven has been replicated in a small scale experiments, but things like gravity and all this, actually that doesn't apply in the same context.
Precisely because if you've been listening to what I was telling you, if you do the calculation and you take two cannonballs, for example, suspend them on two wires, and
giving
you do
them potential energy twofold.
F equals G(m)(1)(m)2) over R². You find the force is so tiny, it simply won't move.
Replicated, mate. The Cavendish experiment's never been replicated.
Cavendish experiment.
What do you mean? What is it?
You say the force is so tiny that
a cannonball, and it's not going to attract the gnat to the cannonball. The only thing what will attract it is the static. Yeah. If you get a balloon and you put it near water, it drags the water with it. That's electricity what's doing it, not gravity.
Mathematics can be used. Tesla, Tesla said scientists are running about with equation after equation.
I feel I'm trying to explain Shakespeare to somebody who doesn't even know how to read.
It doesn't. Oh, mate, that's a bit insulting. That really.
Yes, it is, isn't it? That's where you are.
Do you know what, mate?
Because you're insulting me. Why
am I insulting you?
Discarding the evidence.
Why am I insulting you? Because I told you you're spouting pseudoscience. Second-hand information. I'm not lying to you, mate.
We need to go back to basics.
At that point,
I'm asking you to demonstrate. All right then, mate. You go away then, because we're talking here.
I'll leave it to some people
Goodbye
who are
then.
more
Goodbye then.
tolerant of yours.
Do you know what I mean? No, but I know some people, mate. We was at Portsmouth yesterday, and there was people coming over. There was this one guy who was live feeding, a real life troll he was, yeah? Do you know what I mean? And I was like, as soon as I realised he was live feeding, I stopped talking to him. I started talking to his audience. I was like, look, mate, you don't live on a spinning space ball shooting through an endless vacuum, yeah? Do you know what I mean? I was like, this guy's a whopper. Delete him, block him, get him out your life.
Listen, for people like this, you just need to stop them halfway and say, listen, whatever.
No, he's a crank. Yeah.
For you to pull him up with the ear. You're never going to get him up.
Whatever is written
it's
in
all
paper,
on camera anyway.
Yeah, but see when he lost it with you, that was the type he lost it for you. He started.
Yeah, it's a personal insult. That's what it was. I said you're using pseudoscience. That's not an insult. He personally attacked me. You know what I mean? Are you off, mate?
Yes. And keep.
You really working so hard, guys. I really appreciate your work. Doing all of this everywhere here in England.
I did a presentation at the UK convention. I did a presentation for Moon Race.
What was that?
Basically, I recorded the moon when it's on the tropics of the equator to see what the speed liquid cycle, to see if it matches Kepler's law of planetary motions. And what I found was, to make sure my recordings were accurate, basically I just record the moon and just try to listen to the argument.
It's first-hand empirical evidence.
Well, why? What do you reckon,
no one's
Godwin?
ever seen one. 7 billion people.
Come on, mate. What do you reckon?
I'm listening to both sides of the debate. So what's the debate?
That's fair,
who's arguing?
Because you're listening.
What about the sun? Is the sun flat?
The sun's not 93 million miles.
Is the sun flat? It's round. Is the sun flat? It looks round. It looks round, but that could be an illusion. Sorry. So your argument, your argument about the Earth is we've got evidence. We've got evidence. Well, it's all opinion, but this is opinion.
We're talking about anomalies in space that no one can confirm. Anomalies.
Anomalies in space.
Yeah.
Okay. So you're willing to accept.
None of us have got
the evidence of your naked eyes when it comes to the sun, but when it comes to the Earth, you accept only laser evidence.
No, we're measuring that can see further than my eye. My eye can see 273 miles.
I'm talking to one person. She's shouting in my back.
So what's your
No, it's not.
I've got a 273 mile line of sight test. There's 3 miles of missing curvature. They tell you the height of the observer and the height of the object being observed. So debunk that.
Sorry.
3 miles of missing curvature. Where is it?
Publish the scientific paper.
That's it.
That's a leaflet, sir. You need to understand what you're dealing with here. We're dealing with the modern scientific revolution. If you've got evidence for something which defeats 200 years of science, publish a scientific paper. You won't do it because it'll be thrown out the window. I don't want to talk to you.
Did they look at 400 years ago?
Stop touching me.
Einstein said
Can I ask you?
it's a
400
myth.
years ago, people
I call it a theory. He may say it's a theory. Einstein. But what I know, there's lots of corruptible scientists that were paid years ago to keep their effing mouth shut.
What we need to understand is the Greeks.
All part of the system, part of the secret societies, part of the elitists, part of the New World Order, whatever you want to believe. It's part of the system that we are now in. He couldn't answer that argument scientific.
Honestly, what? You and I are older enough to, people went to the moon. Right. These people basically also believe that the whole moon thing was a fiction. It didn't happen. Do you accept that? Right. We're not sensible, because that kind of exposed millions upon millions of people lying and lying and lying and lying, and no one discovering the truth. I mean, that's a crazy nonsense. We know that people are sensible. We have satellites to see vastly with the Hubble telescope.
Yeah, with the Hubble, how come they've never turned it about? I'm not obviously but why have they never turned it about?
Because it's a deep space satellite. So, if you like, the home bit of the home corner of our space, we know pretty well. We've got instrumentation set up on them. We've got satellites. I mean, they even disagree that they're satellites. They're satellites that are just going around doing measurements, measuring the thickness of the ice, measuring temperatures, measuring animal species, measuring all kinds of stuff on the Amazon. But according to these people, there isn't a single satellite anywhere. Give me a break.
No, there is some theories out there that I wouldn't agree with, but there is some good points too.
Such
as water always being level.
Well, it doesn't. I'm sorry, but if you what you've got to understand is that the horizon is relative. Okay, so depending what height you are above sea level, and depending where you are on the planet, the horizon will look either as a straight line or curved. The closer you are to the equator, the more the horizon looks as if it's curved. So it's completely relative. So you can't draw a single conclusion for all human viewers of the horizon.
No.
It depends where you are and what height you are.
I'm not trying to confuse you just off of that, but it is that one there. It's a pretty good thing because you try and get water around the ball. It doesn't stay there, do you know what I mean? Like,
well, yes, but the Earth is not a pool. The Earth, yes, we would lose our water. Most of the planets in the universe.
Good questions.
Hi, I'm Cosmic Cat, and I write poetry. Hi. Yeah, sweet. Hi, I'm Cosmic Cat, and I write poetry and spoken word on the flat earth, just to help awaken people. Once you go flat, you can't possibly go back. Feet on solid ground, wise internal map. We're all playing the game of life in this three-dimensional realm. Let love and curiosity take over the hijacked hell.
I'm just trying to find that each time. I thought I'd come in a bit early this time. Just talk to someone else. I'm talking to an atheist. Their perspective is yeah, so I think it's nice to come in. Because I haven't done it for a while. I feel like sometimes I haven't got
content over everything from your melody.
Man, say it straight. Man, don't listen to BBC. Man, don't listen to ITV. Listen.
بسم الله الرحمن الرحيم أشهد أن لا إله إلا الله وحده لا شريك له وأشهد أن محمدا عبده ورسوله. First of all, I would like to say Assalamu alaikum, and I would like to condemn the ignorant words spoken by the Salafi Sheikh Abu Ibrahim. He's made a statement